All right, folks, that's it. We're here. This is the last section. Well, last day, I should say. We're doing a little bit more on ellipses. Uh, 10.2, I guess this is B because this is our second day working on it. Ellipses. As a reminder, the form is x minus h squared over a squared plus y minus k squared over b squared equals 1. Oftentimes we don't see it like that, though. We don't see the written as fractions. I guess if we multiply through by a squared and b squared, it would look a little something like this. It would look like b squared times x minus h squared plus a squared times y minus k squared equals a squared b squared. I don't think I've ever written it like that using letters. But it happens a lot. We did several problems like it on Monday. Let's do another one. Let's take a look at one. 49x squared plus 16y squared equals 784. Now I just grabbed this problem off of your book thing. I'm assuming that 49 times 16 is 784. Where's my trusty calculator? 49 times 16, 784. So if we divide both sides by 784 or by 49 over 16, not over 16, but 49 times 16. The right side, it turns into a 1. The left, the 49s cancel on the x squared. We get x squared over 16. And we get y squared over 49. So what does this look like? What is a squared, or what's a and what's b? Or say that again? 4 and 7. 4 and 7. Yeah. So the x tells us how far from HK we're going, left and right. HK, what's the center here on this one? Do I have an HK? Is there anything in the anything with x and y like that? No. So h must be 0 and k must be 0. Center is the origin. So this tells us how far to go left and right. We're going to go left and right 4. And we're going to go up and down 7. And draw a nice rounded ellipse. It's that bottom one, the one on top and bottom are the hardest ones to do. So the ones along which axis here is the major axis? Major axis is the Y. Why? It's the longer one, right? It's the longer one. The endpoints on the major axis are called the vertices. So that's vertex 1, or vertex A, vertex B. The vertices, which is plural for it, vertex, are at the ends of the major axis. And they're really movement from the center. My center is 0, 0, and they are along the major axis. So it's going to be 0 and then 0 plus or minus B. In this case, 0, 7 and 0, negative 7. What about the foci? The foci are along the major axis as well, but they are plus or minus C, where C is found by doing C squared is the absolute value of A squared minus B squared. So for this one, what is that, 33? So C equals the square root of 33. 25 would be 5 and 36 would be 6. I'm guessing this is around 5.8. What was it?
5.7.
Close. Estimating is a skill. I don't need a calculator all the time. I get close enough, usually for like, if there's no reason I'm gonna have square roots and shit in like grocery shopping.
Yeah.
But I estimate, like if I'm out in the grocery store, I will have cash, and it fucking sucks walking up to that goddamn counter and not having enough money. You look poor as fuck. Doesn't matter if you're not. If you don't have enough money on you, you're like, all right, I gotta get out my card. That's the motherfucker when that gets declined for like whatever reason. So like they sent you a new one, you didn't fucking check the mail recently, and whatever the reason. Or you just don't have any money. So this will go up 5.8, 1, 2, 3, 4, 5.8, and down 5.8. And that's our foci right there. You ready for some more? All right. Write the equation of an ellipse. Centered at the origin. With foci at plus or minus 5, 0, and a major axis of length 18. So let's pull this apart for what we know. Centered at the origin means HK is 0, 0. What does the bit about foci at plus or minus 5 tell us? What?
The x-axis.
It tells us the major axis is the x-axis, right? What else does it give us?
X-axis like the 18.
Well, I mean, just with the foci at plus or minus 5, 0. There's another piece of information we can extract from this.
Slide 0, negative 5, 0.
And what does the 5, 0, negative 5, 0 tell us? C has to equal 5. Because the distance from the center for a focus is C. Which means C squared is going to equal 25. And what does major axis of length 18 give us?
The whole length of the ellipse.
It gives us the whole length of the ellipse. We know it's along the x-axis because that's where the foci are. So like if this, I guess I should count them out. 5, 1, 2, 3, 4, 5. The major axis is split up half and half going each direction, right? So we should have past where our foci are. Should be another 4 steps to the edge, to our vertex. Which gives us one more piece of information. This is what we're trying to fill in here. What did we acquire with this piece of information?
A is not.
We got A. A is 9, and we got the length of the major axis. This is gonna be A equals 9. We can extract that from our major axis of A and T. We know A is 9, we know H is 0, and we know K is 0. The only thing we're missing is that. How can we find B?
Like, looking at everything, solve for you.
We could pick a point on there and do that. But we don't have the rest of the ellipse, so I don't know. I can't use other points other than the vertices. Like right now, we are at x squared over 81 plus y squared over blank equals 1. So even if I plug in like 90 or negative 90, which are both on the ellipse, this is going to give us a 1, this is going to give us a 0, and it doesn't tell us what B is.
So we use the equation for the foci.
We can use the C. What's the equation for the foci?
C squared equals the absolute value of B squared minus B squared.
Good. A is the major axis, so we know A is bigger than B, right? So A squared is going to be bigger than C squared or B squared, so we don't really need the major axis or the absolute values at this point. We know A is bigger than B. And so we have 25 equals 81 minus B squared. The way you can quickly find out if you don't know is plug it in, and if you end up getting the number squared equals a negative number, you need the absolute values. Here we're not going to need it though, because if I subtract 81 from both sides, what do I get? 25, 50, negative 56 equals negative B squared. So positive 56 equals positive B squared. Is that the right number? 56 and 25 add up to 81, yeah. So B is the square root of 56. .49 would be 7, 64 would be 8. This is about halfway between them. I'm going to guess that's about 75. But all we really needed was B squared. That's what goes in the equation. If I need to graph it, I need that B. .5.
I don't get it. So it's gonna be 8 up and 8 down.
It's not 8. It's about it's square root of 56.
Square of 56.
Which is close to 8. It's about 7.5.
Oh, okay.
Sometimes they throw us a little curveball. Let's take a look at a curveball real quick. Maybe I'll start on this page, make sure I don't run out of paper today. Graph y/3 equals negative square root of 1 minus x squared over 4. Now, if you see some crazy shit like this, you might be inclined to go, fuck all that. This looks rough. And then if you're like, I really need to do this, is on a test, go, okay, I'll just plug in some values for x and see what I get. When you have a square root, the better thing to do is like square everything, try to see if you can identify a shape out of it. So we're gonna square everything, square both sides. And I get y squared over 9 equals, the negative goes away, negative times a negative is positive, the square root goes away, and I get 1 minus x squared over 4. So if I add x squared over 4 to the other side, I have x squared over 4 plus y squared over 9 equals 1. And this looks like an ellipse. But we have a restriction from the beginning. Y/3 has to equal negative square root, which means y/3, or y, has to be less than 0, less than or equal to 0. Because the square root's always going to spit out a positive number, but the negative is going to make it negative. So we don't have a full ellipse, we have the bottom half of an ellipse. So if we were doing x squared over 4 plus y squared over 9, what is a and b here? Two and 3. I don't have an HK, which means the center is the origin. So I'm going to go left and right, 2, up and down, 3. But I'm not doing the top half. I'm only doing the bottom half, because it's got to be negative. So it's only this part right here. I was able to get that all in on one page. Go me.
I don't understand, like, what is -2, what is +2, and why is like 2.5, -2.5 down.
It's 3 down,
But why? Like, I don't understand why.
because the square root of these The numbers below x squared and y squared say how far away they are. That is a squared, that is
Okay.
b squared. So that gives us a and b. And the ellipse, you go left a and right a, you go up b and you go down b from the center.
Oh, okay, now I understand. But what is like half of it?
Because up here it said negative, which
So
meant we didn't have the full ellipse. Because we didn't start with the equation of ellipse, we squared to get the equation of the ellipse. But we started with y over
negative.
3 equals a negative number. So y has to be negative, which means it's below the x-axis.
Those positive would be the whole thing or Steve's on
If it was positive, it'd just be the top half. If we wanted the full thing, we wouldn't ever have a square root in it at all. It's the
But
fact that we started off with a square root that makes it only half of it.
just the question I have, if it is negative, it's always like this, or there's other exceptions, like for example, not horizontally incomplete, but vertically incomplete.
Yeah, you would have, if you had something like x over 3 equal negative square root of 1 minus y squared over 4. Now here, x is negative. X has to be less than or equal to 0. Because this is a positive number, but we got a negative. So you're looking at an ellipse that would only be the left half.
Okay.
And if it was positive, it would be the right half.
Okay.
Oh,
If the x is in the other side and the y is in the other side, that's like vertically incomplete. And also if it is negative,
The square root is making it incomplete.
it's kind of hard to understand. Okay.
There's a square root here, and there was not a square root here. That's what's changed.
Okay.
Here, we didn't have a square root. Here, we had square roots. The square root is making it so we don't have the whole graph.
Okay, I got it right now.
Just like if you had y equals x squared or x equals square root of y.
Okay.
That's not a great example. You're not used to seeing it. Y equals x squared is the whole thing. X equals square root of y is just the positive half. Because the x has to be positive because it's the square root. Square roots always spit out positive numbers. They don't spit out negatives. So this with the red would be x equals square root of y. Another way you would see it, you're more likely to have seen this, is when we do y equals square root of x. Y equals square root of x looks like this. That's the graph we've done the graph of y equals square root of x before. But if you square both sides here, you get y squared equals x. And the graph of y squared equals x includes the other side. So the square root cuts your thing in half.
Mm.
And if you're still stuck on that, I'll have to go over it with you more later. We got to keep going.
Yeah, it's fine. Don't worry.
All right, let's take a look at x minus 3 squared over 36 plus y plus 2 squared over 25. What is my A and my B here? Tells me how far we're gonna go left and right and up and down. 6 and 5, right? What is my center? 3 and -2. Which means our center is not the origin anymore. We need to move to compensate for it. Okay, the easiest way to go about graphing this is just make dots, go left and right A. And I would recommend just making little dots as you do them and counting it. If I go left A, I go left 6. 1, 2, 3, 4, 5, 6. Then I gotta go right A. 1, 2, 3, 4, 5, 6. Alternatively, you can calculate what the coordinate is and then go to the coordinate the other way. For B equals 5, I'm gonna go up and down 5. So I'm gonna go up 5. And down 5. And then we make a little curve to connect it. And it looks close to a circle. Right? That's because A and B are almost the same length. In fact, that's the difference between an ellipse and the circle. The circle A equals B. And so then you have x minus h squared over a squared plus y minus k squared over b squared equals 1. A equals b and it equals r, the radius. This turns into x minus h squared over r squared plus y minus k squared over r squared equals 1. And then that's where we don't leave it as fractions. We never write circles as that. We've always written circles like this. But that's the difference between an ellipse and a circle. For a circle, A equals B equal to R. Which means C equals, for a circle, zero. So that leads to one more topic in this, well, not one more, but the next topic before some applications, eccentricity. Eccentricity is a measure of how much a conic shape deviates from a circle. Before the other thing with the circle, since A equals B equals R, this merges the two foci into the center. The closer A and B are, the closer the foci are to the center. And when they equal each other, they're like overlap. There's only one point left. And unfortunately, and this is fucking tragic, they give the letter E to eccentricity, which is terrible because we use E as a natural number. It's 2.71, completely different E. E equals C over the semi-major. Semi-major is half the length of the major axis. For parabolas, which we did in 10.1, E equals 1. Ellipses, the eccentricity is always between 0 and 1. Well, not 1 and not 0. No equal sign. And for a circle, well, circle C squared equals A squared minus B squared. And on a circle, A squared equals B squared, so C squared equals 0 on a circle. And E is C over some number, 0 over any number, E equals 0 for a circle. Another way of putting this is kind of like it measures roundness. I have a high eccentricity. I am very round. Let's take a look at that last problem we did. The last problem we did, we had x minus 3 squared over 36. I didn't write the fucking square there. Y plus 2 squared over 25 equals 1. C squared is A squared minus B squared. 36 minus 25 equals 11. So C equals the square root of 11. My major axis is X. And so the length of the major axis is 2A. Or 2B. In this case, 2A because it's a long X. So half the length, the semi-major is A or B. Which means eccentricity is, for that problem, square root of 11 over A, which was 6. .55. Approximately 0.55. So, where does this come up a lot? Well, if we look at our solar system, what things do ellipses belong to? Planet orbits are elliptical. In fact, the sun is one of the foci. That's fun. So we could do something like the orbit of Jupiter. Jupiter's orbit it has an eccentricity of 0.0489. It is not very round. It's pretty flat. Wait, circles are zeros, so it's closer to 0. It's actually pretty flat, or pretty round. And the maximum distance Jupiter is from the sun is 507.4 million miles. We can use this information to find the closest it is to the sun. And the closest distance. Or shortest distance, I guess, is the better way. Curved over here. So let's just draw an ellipse and picture what's going on here. I'm going to make it look not so round, even though its eccentricity is close to 0. The sun is burning right back in here. We're going to call that one of the foci. There's another foci over here somewhere. And nothing there though. The sun is there. Which direction is going to be the maximum distance from the sun? left along the
That's
major
correct.
axis, right? That distance should be the 507.4 million miles.
The point, is there nothing there, that's the other. Okay.
The other foci point or focal point? There's only the planets and the sun in our solar system, there's nothing there. The gravity of the sun is causing it, does the slingshot or that. It slingshots, accelerates, as it's coming in, it accelerates from the sun, pulling it faster. It whips it around, and that's why the speed forces it out. The sun slowly pulls it in, and it starts pull. Starts speeding up, whips around. I've exaggerated the major axis here. It's pretty close to a circle here. The center would be here, which means this distance here is A. And this distance here is C. So from our picture, we can see A plus C equals 507.4. Which means I could say C equals 507.4 minus A, where this is all in millions of miles. Reason why I say that is because that'll help us with the eccentricity. Eccentricity 0.0489. That equals C over A, but C is 507.4 minus A all over A. So if I clear fractions, I'm multiplying by A. To solve this, I'd get A on the other side, add A to both sides. I get 1.0489 A equals 507.4 million still. And so A equals 507.4 million over that 1.0489. A is approximately 460.1 million miles. That gives us a little more information. That's not what we're looking for, though. That's the distance from the center to the edge of the ellipse. We want the closest Jupiter is to the sun would be right here. That would be closest. This would get us the shortest distance. I'm gonna call that S. S equals shortest. I can see from my picture here that C plus S should equal A. So S is gonna be A minus C. If I subtract C from both sides. I have A. I need C. I can get C though. I had C listed as 507.4 minus A. So 507.4 minus 460.1. That's not A. I think I wrote down the wrong number for A. I think 460.1 was the final answer. Let me double check this. 507.4 divided by 1.04. Fuck you. God damn it. How hard do I gotta hit the goddamn button? Yeah, I said it wrong. That was 483.7. 4.5. We throw in some more decimal places. So minus 483.745. We end up getting C is 507.4 minus that, 23.655. So we'll do that with our S. S equals S equals A, which is 483.745 minus C, which is 23.655, and these are in millions. That's where we get the 460.1 million. Other things these ellipses have been used for, I don't know if they use them for something similar to it now. They used to use elliptical mirrors to focus sound waves. Like put elliptical mirrors around the body with the focal point as one of the kidney stones, and use sound waves to break up kidney stones. Another one is something called, and you should look this up because this is really fucking interesting. Look up whispering galleries. The idea basically being, if you have two foci, any sound emitted from it hits the other foci. So anyone talking on one foci, doesn't matter how big this room is, if the room is elliptical or has this shape, you can stand on the other foci focus point, even if it's 100 feet away, and they could be fucking whispering, and you can hear them clear as day. Benjamin Franklin did this in Independence Hall during politics. He fucking knew how that shit worked. He put his desk on a fucking focal point, and he didn't talk while he was at it. He just listened. He had the other desks of his political rivals were on the others near the other focal point. They would talk. He'd sit there, fucking eavesdrop on their conversation. If you visit Congressional Hall or I don't know if they'll show you an Independence Hall, but if you visit, like Supreme Court has a whispering gallery underneath it, where they've done, or where they used to hold Congress, and the tour will have you do the whispering gallery. Now you really got to be right at the fucking focal point. So like even if you're a foot off, you don't hear it hardly as well. So they'll make everybody like on a tour, cluster your fucking heads as close as you can together to that thing, and the dude will walk off a ways and just start talking, and he'll talk the same volume, and his voice will taper off, and then he gets to the fucking sweet spot, and all of a sudden it's like he's yelling in your ear. It's fucking neat.
You did it before?
Yeah. Let's take a 5-minute break, then we'll do hyperbolas. On to our final section, 10.3, hyperbolas. Then I want it up and I didn't have it fucking ready. Few of them you're very familiar with in real life. It's not what I wanted. One of them is the Gateway Arch in St. Louis. You've seen the pictures. It is part of a hyperbola. Another thing that has hyperbolic form are cooling towers for energy plants. So these have real life purposes. This is where the fun ends. The equation looks a shitload like on the left. Check this out. X minus h squared over a squared. We got y minus k squared over b squared equals 1. The only difference is there's a minus between them. Or we could have it where the other one is negative. We would do the y one first. We do y minus x. The one that's positive, the term that's positive, shows you how the hyperbola is open. Call that A and B. A, the x term is positive. So you get, it almost looks like two parabolas. It looks like two parabolas. And when the y term is positive, you get it where it opens up and down. So I'm going to use the X1 to just do some big picture or generalized pictures. So let's say we've got that going on.
Can you just come back to the picture?
I didn't write that much. Thought you were done.
Oh, a little bit of.
More?
Yeah, a little bit of. Oh, never mind. I took the notes. I thought there was something else. Sorry.
I'm gonna slap you, Josue. If only I could reach to this monitor. You're safe. I'll forget by the time I see you for the final. All right. I never hit a student. That's a quick way to, that's one of the few ways I could lose my job.
That's always the first time. So
Nope. That's the day I want to quit my job and I've got enough money that I can retire. Then I have too much money and then I'm
well,
gonna get
I can sue you so I can get some money.
That's what I was saying. I was just about to say, I don't want to get sued. So if I want to quit my job, I'm not going out with like striking a student, but I will bring like Jello shots or some shit like that. We'll have a fucking party and that'll quickly get back to the dean. Fuck Jones is bringing vodka in. That's my ass. Don't fucking find reason to fire me then. So we have like, let's say it's centered at the origin. So let's say centered at the origin, but it doesn't necessarily have to be centered at the origin. The axis that cuts them in half, this bad boy is called the transverse axis. And the other one is called the conjugate axis. This is still a distance A from the center. A that way, A that way. For the X one, for the B one, or for the Y one, it would be B because you're going up and down. So where does the B come in? If we go up and down B, what you do is you make a box. These points right here on the transverse axis are still called the vertices. These points are called covertexes. It's a covertex. So covertices. And same up top. So when you make this box, what you do is you connect the lines diagonally and make it with a dashed line. These dashed lines are asymptotes. So the hyperbola graph approaches them. And finally, our focus, we have foci here, we have foci here. They're in the dish part of it. They're still out a distance C from the center. But to get C for the foci, C squared equals A squared plus B squared for an ellipse, or for a hyperbola. I didn't remember the name transverse or conjugate axis. I never remember transverse, I'll remember sometimes. Conjugate now. Ellipses, it's easy to remember major and minor axis. So let's just do a general ellipse, give you some practice, or not ellipse, hyperbola. We're gonna do x squared over 4 minus y squared over 25 equals 1. So what does A equal and what does B equal?
Two, B is 5.
B is 5. Where's the center? What? We have a center.
Squared, so I squared.
It should be, if you don't have an H and a K, it's 0, 0. Well, that's still a spot. When you say we don't have one, that doesn't mean 0, 0 to me. That is a spot. All right, so what you do is we go to 0, 0. We count out 2 in the left and right direction, 5 in the up and down direction. And we make a box. Asymptotes go through the diagonals. This is how you start every ellipse. You make the box, get the asymptotes. Now, the only thing that's left is to draw the damn ellipse, or not ellipse, hyperbola. Whatever one's the positive one, that's the axis you're breaking, you're gonna use go from. You go to the box where those points are, and you just draw a curve that's approaching the asymptote. So where are my vertices at on this picture?
Two. Two.
2, 0 and negative 2, 0. But yeah. I'm gonna get points for them. Where are the foci? Well, we gotta find them. We're gonna do c squared equals a squared plus b squared, which is 4 plus 25, which is 29. So c equals the square root of 29. And our foci are at plus or minus square root of 29, 0, which is about 5. Well, a little over 5. 5.3, 5.4. 3, 4, 5, 6. So like right around there. And there. Can I find the equations for the lines for the asymptotes? Where is my red? Better print this on the page. Let's look at the lines for the asymptotes. Well, the equation for a line is, well, we got y equals mx plus b is a way we can do it, or y minus y1 equals m times x minus x1. What are my m's?
2 and -2.
What?
The 2 and -2.
No,
Is it 1?
no. M is slope.
So,
So we went up 5 and we went over 2. Rise over run. Which actually ends up just being b over a. Or negative b over a for the one on the left. The one that goes downhill would be negative b over a. So the slope is really easy to get because you already have the numbers. And a vertex goes through the hyperbola, so the easiest way to get the equation for the line is use this one and use a vertex. So we had 2, 0 was one of our vertices. Vertex was 2, 0. My m for this is a was 2 and b was 5. So we got 5 halves and negative 5 halves. My equation is y minus 0 equals 5 halves times x minus 2. And then the other one is y minus 0 equals negative 5 halves times x minus 2. Those are the asymptotes. If you remember the general formula for a line, and what slope means, they literally fall right out from what you have from that hyperbola. Now, if you try to do eccentricity here, square root of 29 over 2 ends up being greater than 1. Hyperbolas have an eccentricity greater than 1. And we generally don't talk about it. Generally don't discuss eccentricity for ellipses. Not ellipses, hyperbolas. I keep saying ellipses. Guys ready for some more?
Yeah. Get ready.
Let's do this one. 4y squared minus 25x squared equals 100. So we got to divide everything by 100 because we want the right side to equal 1. And we get y squared over 25 minus x squared over 4 equals 1. Which means, just like our last problem, a equals 2 and b equals 5. C is square root of 29. We just did this in the last problem. We still make our box the same way.
All right, are you going down there now?
And we're still gonna do our asymptotes. And even our asymptote equations are the same. But one thing has changed. Here, the y term is positive. So it's going to be like this. So our vertices are along the y-axis now. And they go towards the asymptotes. And so whereas this made really wide dishes, this is really narrow. All right, let me give you guys one to try where we have it adjusted. It's no longer at the center, or no longer at the origin. We're gonna do x minus 2 squared over 16 minus y plus 4 squared equals 1. What is A and B here? 4 and 1. The B was sneaky, wasn't it? Which way does it open? It goes left and right. It doesn't hurt to draw a little sketch of what you're looking for now while it's in your head at the beginning.
Just a minute. How you know what way it opens?
By which term is positive?
Okay.
There's a negative with the y, the x one is positive, so they open in the x direction.
You should focus on the X to know it.
It's whichever term is positive. Look at this one up here.
Yeah,
The one up here, the positive term was y, and they opened up and down.
yeah.
On this one, the positive term is x, so they open left and right. Left and right is the x directions.
Okay, let me see. Okay. Okay, got it now.
Okay, good, because I don't have any other way of explaining that. Left and right and up and down is about as simple as I can make it. All right, so let's graph it. Where's my center? Two and -4. All right, so it looks like we're gonna be down in the lower right. Guess I'll put some more hash marks over here. All right, so we gotta make our box. A is left and right 4. 1, 2, 3, 4. 1, 2, 3, 4. And I go only up and down only 1. Which means my box is like this. If I drew it a little bit better. I recommend when you're doing the asymptotes, start at the center and draw it towards the corners. That's the easiest way to end up with a fucking straight line. If you try to start outside the box and draw inward, you're gonna get it wrong. It's gonna look like shit. We said left and right, so we're going like this. What are the vertices here? What? -2, -4 is one of them. 6 and -4 is the other. The easiest way to go about doing this, rather than trying to like fucking line it up and count them, is do h plus or minus a comma k. So -2 plus or minus 4 comma, not -2, +2 plus or minus 4 comma k, which was -4. If it opens up and down, the vertices are at h and then k plus or minus b. But that's a different problem. So that's easier to do than trying to like line up the thing. Where are the foci at? Foci, you set it the same way, but you're doing h plus or minus c. So what is C here? C squared is A squared plus B squared. 16 plus 1 is 17. So C is the square root of 17. I'm just going to write this as -2 plus the square root of 17, -4, and -2 minus the square root of 17, -4. Square root of 17 isn't very much more than 4. It's like 4.1, 4.2, maybe 4.15. It's only a little tiny bit past your vertices. So those are my F's. That's my B. And what about our asymptotes? So remember, we're going to do y minus y1 equals m times x minus x1, where m is plus or minus b over a. One and 4, yeah. We go up 1 and we go right 4. So plus or minus 1 over 4. Now you just got to pick a vertex, not the center. The center is not on the graph. So we got to pick a vertex. We got one up here, the -2, -4. So you can do y minus -2, -4 equals 1/4 x minus -2, which ends up being y plus 4 equals 1/4 x plus 2. And the other option you'll end up having is y plus 4 equals -1/4 times x plus 2. Those are the two asymptotes. If you want to solve them for y and write them in y equals mx plus b form, you can. The review is up in the module along with the answer key. There are more problems on the review than in the actual test. For example, the review has a complete the square with both an ellipse and a hyperbola. The actual test is only going to have one of them, and I'm not telling you which one. But they're done the same way. They look, the ellipses and hyperbolas look the same, just other than one sign difference. So let's do one more complete the square here. Let's do, we're going to do 9x squared plus 36x minus y squared plus 10y plus 2 equals 0. So we break them up. I'm going to do the x squared here. We're going to factor out a 9. Factor out the coefficient on the x squared. and factor out the coefficient on the y squared, which in this case is only a minus sign. 36 divided by 9 is going to give me a 4, so that's a 4x there. 10 divided by, this is like a -1 here. 10 divided by -1 is just -10 there. And I'm going to move the 2 to the other side by subtracting it. All right, Luis, help me with this. I know this was your favorite thing on Monday. How do I complete the square? Jimmy's not here to throw under the bus, so I gotta use you. We take this, we cut it in half, and square it. So this is gonna turn into 9 times x plus 2 squared. We take that, we cut it in half, and then we square it. -5 squared is 25. And this will be minus y minus 5 squared. All right, I didn't just add 4, I added 4 times 9, which means I'm going to do this over here as well. 4 times 9 is 36. We're going to add 36 over here. Here I have add 25, but it's multiplied by -1. So I really subtracted 25. So I'm going to subtract 25 over here. And 36 minus 27 is 9. So that's what the right side will equal, is 9. Divide by 9. We want the right side to equal 1. And we get x plus 2 squared over 9, or over 1, minus y minus 5 squared over 9 equals 1. So what is my A and what is my B? 1 and 3. Where is my center?
-2 and 5.
-2 and 5. Am I opening left or right or up and down?
Left one.
Left and right. With that, before I even grab it, I can tell them right away where my vertices are. My vertices are going to be at, since we're doing left and right, we add a to the x part. -2 plus or minus 1, 5. So we've got -3, 5 and -1, 5. my foci are at -2 plus or minus c, comma 5. What is c here? C squared equals a squared plus b squared. So 10, so c equals square root of 10. So -2 plus or minus square root of 10, comma 5. That's about 3 point, I don't know, 1, 2, maybe 2, 3.16 maybe. But we know it's to the left or the right. You draw it. -2, 5 is in the upper left. It's over here. And I got a little tiny box. We're only going left or right 1. And we're only going up or down 3. And we're going left and right, so they open towards the asymptotes. And this looks really flat. My slope for my asymptotes is plus or minus b over a, which is plus or minus 3. So we're going to do y minus y1 equals plus or minus 3 times x minus x1. We'll pick a vertex. -1, 5 looks good. Y minus 5 equals plus or minus 3 times x minus -1 is going to be plus 1. So those are the asymptotes. Ooh. What's the domain and the range? So the domain, it looks like it keeps opening to the left and right. So the domain starts at -infinity and it goes all the way up to the vertex is the furthest point on the right, which is at -3. And we got a bracket because it includes it. And then the hyperbola starts back up at -1. What about the range? -infinity to infinity, yeah. That's it. That's college algebra for you. We have our final next Monday. Same bat time, same bat place. If you are free on Saturday morning, I'm gonna be in the Mesa Center in Visalia. From 9 AM till 12, if you have any last minute questions and wanna talk to me in person. It's in the John Muir Building. So Saturday. 9 AM to 12 noon. John Muir. I wanna say it's like room 124, there's directions to the Mesa Center. Out there, if you go from the parking lot right next to it. There's an open gate, you go in the gate, there's only one door open, you'll see it. I keep the door propped open. So that students can find it relatively easy. Other than that, we're end of line, that's it.
I mean, I just have a question because I just have some assignments left, but as long as I finish them before the 15th of December, I'm gonna be fine.
They're due on the day of the final.
Oh, they're due. Oh, okay, then that's fine.
I don't know where you got 15th.
What happened?
I don't know where you got 15th of December from,
Oh, okay then.
but yeah, day of
It's
final,
just a
which
question.
is. Other than that,
Thank you. Have a good day.
you too.